Alright, in this video, we would like to continue our discussion about formation of ions, and hopefully we can cover a covalent bond as well. Okay, so let's use a couple more examples to enhance our concept about valence electrons and octet loop. So, for example, if you look at the magnesium, which is Mg in the periodic table, excuse me. Number 12 has a mass number about 24. Alright, so let's see if we can draw the atomic diagram here for magnesium. You can pause the video here, see if you try it. Alright, so magnesium is Mg with atomic number 12, so that means 12 protons. Mass number is 24, minus 12, that means there are 12 neutrons. And there are 12 electrons as well. Okay, as neutral atom. So this 12 electrons will look like this. 2 electrons on the first layer, 8 electrons on the second layer. On the third layer, you have 2 electrons as well. Okay, so you can see valence electrons are these 2 electrons. Okay, on the third layer. Now let's look at the oxygen. Okay, oxygen has a symbol of O, which is number 8. Has mass number 16, atomic number 8, so 16 minus 8 equals to 8. That means there are 8 protons and 8 neutrons and 8 electrons. 8 electrons, there are 2 electrons on the first layer and 6 electrons on the second layer. Valence electrons are these 6 electrons. Okay, now imagine when magnesium reacts with the oxygen atom, what's going to happen is magnesium, since only has 2 electrons, okay, now think about number 8, so the magic number is really 8, okay. Everybody wants to have 8 valence electrons. So the key, so where it splits is number 4. Now you can imagine if you have more than 4 electrons, like oxygen or fluorine or chlorine, okay, they may have 6 or 7 electrons. It will be way easier for them to get maybe 1 or 2 electrons to become 8. Whereas for the elements, they have less than 4, which is exactly half of 8. Okay, if they have less than half of 8, like magnesium or sodium from previous video, they only have 1 or 2 valence electrons. It will be much easier for them just get rid of those extra electrons instead of getting 6 more or 7 more. Okay, so I think that's easy to understand. So for magnesium, it's always looking for someone they can donate these 2 electrons to. For oxygen, it's always looking for the source of 2 more electrons. So when magnesium meets oxygen, so the deal is very simple. The magnesium is going to lose these 2 electrons, and they're going to go to oxygen. Okay, so once they come up with the deal like that, so what's going to happen? The result is going to be magnesium becomes like this. Okay, losing 2 electrons, where oxygen becomes 8 valence electrons as well. So you can see there's number 8 and number 8 on both. Okay, except magnesium will look like this. It still has 12 protons, so it doesn't change what the element is, except it has positive 2 charge. For oxygen here, because of gaining 2 more electrons, that makes it negative 2 charge. So we say, okay, there's a cation and there's an anion. They both are ions, so they form an ionic bond between the magnesium and oxygen. So this is an ionic compound. Now, when you have electrons completely transferred away from one atom, you become positive charge, you lose electrons. And when you have someone completely accept those 2 electrons, like oxygen here, then it becomes negative 2 charge. This happens when you have electrons fully transferred from one atom to the other atom. But there are also cases that when you cannot do that. Okay, for example, let's look at the fluorine. Okay, now fluorine is number 9. Okay, number 9. So let's skip the proton neutron part. Okay, it has 9 proton, 9 electrons. So 2 electrons and 7 electrons. Okay, now fluorine obviously is looking for 1 more electron. If there's something like magnesium or sodium, who is willing to donate 1 electron, then we'll be perfectly happy. But the thing is, well, if there's nobody else around, if there's only fluorine, what is it going to do? Obviously, it's not going to stay as 7 electrons. It's going to do everything to be 8 electrons. Okay, so what it's going to do is it's going to find another fluorine atom. So let's redraw fluorine. Okay, so let's say this is fluorine, and it has 2 electrons on the first layer. It has, oh, excuse me, it has 7 electrons. Okay, of course, ideally you would like to have 8, but it just doesn't have 8. Okay, it has 7 electrons. And the other fluorine, and we're talking about a bunch of fluorine atoms, right? So 2 electrons in the inner layer, which is not going to be involved in chemistry, but it also has a second layer which is missing 1 electron. So what they're going to do between these 2 fluorine, they both are missing 1 electron, is they're going to try to share. Instead of transferring 1 electron to the other, you can't move 1 electron to the other. Okay, that's not going to happen, because yes, you would have 8, but on the other side you only have 6. That will make it worse. So what's going to happen is, instead of transferring electron from one atom to the other, they're going to share 2 electrons. Now, by sharing 2 electrons, well, of course, that means they're going to hang out together all the time, going to stuck together. But by sharing 2 electrons, okay, at least make it look like this fluorine. Now it has 1, 2, 3, 4, 5, 6, 7, 8 electrons. It will look like this fluorine has 8 electrons. Similarly, the other fluorine will make it doesn't have, okay, but it make it look like it has 8 electrons as well. So they both are happy. Okay, so here there's no electron transferring from one atom to another atom. They're gonna form a so-called covalent bond. Covalent means they're sharing valence electrons. Okay, covalent bond usually you will be on the paper, okay, will be represented by a dash line, short dash line, okay, and you use a symbol fluorine on one end, another fluorine on the other end. That means these 2 are bound together through one dash line, means through one pair of 2 electrons. Okay, the shared electrons between them. So here we're introducing, touch base with you guys about 2 basic type of bonds. Okay, ionic bond, covalent bond. So in other words, we also call this type of compound, okay, covalent compound. It actually has another name, molecular compound. Okay, so this is the chemical property of fluorine. It does form covalent bond with itself. But like I said, if there's anything else around it, like sodium, magnesium, who would be willing to donate electrons, then these fluorine would go look for additional electrons from them. But if not, fluorine element by itself, that's the way they exist. A similar example to fluorine you can also find in some other gases, like hydrogen gas, or oxygen gas, or chlorine gas, bromine, okay. You can nitrogen gas, very similar. Okay, most of these diatomic gaseous molecules are covalent bonded between 2 atoms.